So we have another send in here. This time it's a Game Boy Pocket. It's come in one of our cool clear red shells. We have an IPS screen kit, a clean amp and a clean power. So the main issues are that the device won't power on. That's the one I'm interested in. So it just won't power on at all from battery or DC. And then the others are simply installing a clean amp, a clean power, the screen. That's not really a repair. So I'll do that off video. Let's just focus on trying to fix this Game Boy Pocket and take a look at why it won't power. Normally, no powers are pretty easy and quick to fix. So let's just take a look at this. Just bring the scope over. And if we take a look, we can see here's the list of issues. So we have that it won't power on as the main one we're interested in, and a bunch of other small things. So let's just take a look at the top issue for now. And here is the Game Boy Pocket. Let's just do a quick visual first. So we can see that the kind of dull appearance of solder joints like this does indicate normally acid corrosion. So, and then there's a little speck of blue there, which is battery acid. So this has obviously had some battery acid damage. I think if you look in here as well, there's good telltale signs there that the DC jack has got some battery acid on. So probably want to replace that. Oh, sorry, it's the headphone jack. So probably wants a really good clean. A good one is to warm vinegar in the microwave and then soak this in. So I can do that afterwards. I can repair this again off camera, but I'll just dip that in white vinegar that's warm and then get some IPA and give it a good clean to get this headphone jack up and running. Let's take a look at the other side. So no power, we want to focus around the power area. Battery terminals look clean, so it doesn't look like it's been a typical battery corrosion issue unless it's had new springs, but you can also see inside the spring solder joint there is blue, so again it's had battery acid leaking there. So maybe it is battery acid leaking, it's just leaked in a slightly different way. Let's take a look around here. It's had some rework here by the looks of it, but again all this is dull. It wouldn't normally be dull, so there's been acid on this board. The telltales for no power are checking this fuse and this fuse to see if they are good. This one is just a low ohm resistor that blows when it's over current, so it's kind of a makeshift fuse. And this one's labelled D3 like it's a diode, but in brackets F2. And it's got a 0.5 amp rating potentially there, but that can easily be swapped just with an 0603 1.25 amp fuse. So we could always swap that if it was bad. So first things first, let me just get my bench power supply up and running. And I've got it set to 3 volts. And then what I'm looking for when I grip on here is if I get any power draw. So if I turn the console on, I get absolutely zero amps being drawn. So this thing isn't powering on, and you could tell by the LED as well. So if I was to grip on there and turn it on this way, you can see there's no power light. So this has got no power there. Another few tests we can do is some continuity tests. So let's just do some basic ones. Let's do ground to ground. To ground. Okay, so we're not getting ground already. So down here is ground. Down here is ground. So let's just check if these are working. And you can see I don't have the multimeter beeping at the minute because it annoys people with the really loud beep until I lower the power of the speaker. But if you look at the multimeter on the screen, if I touch on here and say I touch these together, you can see it gives me a reading of 0 ohms, so that's continuity. So if I touch over these two, you can see I've got 0 ohms, so that's making continuity. And then if I touch on here, from the battery spring to here, it's open. So we're not getting connection from the battery spring to the ground here, but from this ground to this ground, we're getting ground there. Let's scratch through the base there. I think actually pin 4 is the main ground on there, so we've got ground to that point. But the main thing is we don't have ground to here, so the first thing we can do is we could look for where this ground breaks. I believe it comes over here through these pads here, which also look like they've got acid corrosion. So likely the ground's broke here, where you see the via is corroded. So let's just gently scrape away a little bit of that. Let's touch on there, and let's touch on that pad, and now we've got continuity there. So the ground wants to go through here, and if we flip over, the two vias come out here by the start button. So the ground then comes through to this side. So let's just scrape off near here as well, and let's see if that via is good or not. And it doesn't look good anyway, because it's got battery acid in, so I'll probably replace it with a jumper wire. But now if we touch on there, and the battery terminal, which is just here, have we made it through? Barely. So you see how we've got like 15 ohms. That's not good. It wants to be absolutely 0. Scratch through that. Yeah, so we have made it through the via. So even though it doesn't look like it, we have. But we're probably going to replace the root of ground anyway. You can see it comes down, goes through, and goes into this DC jack. And this is also a common fault. I think I mentioned it on one of the early videos I did, that the ground actually comes into the DC jack on pin 3 and goes through, and I can't remember which one it is, to be honest. But I know it comes through, comes through 3 and then carries out on the rest of the board on one of these other pins. And if I try to remember which one that is, I could look at the schematic or get a working board to find out. But the quick one is, I'm guessing, see, we have power there, which maybe me scratching these vias has made it slightly connect, because yeah, we don't get a connection there. That's because, yeah. Oh, so actually, once we get to the other side, we have connection to this 3. So the connection looks like it's actually broken from, as simple as it sounds, from here, coming through, and getting right to here that looks like it's connected perfectly. But it doesn't appear to have connection. So if I take ground there, and the pad here, so just the two grounds in essence right next to each other, we have ground. We have ground. Strange. So this one is balling out on and off like we have ground and we don't have ground. So it's probably just to do with the fact that we have a bad via here that's got battery acid. So when you do actually go on the battery spring and you go to, say, this connection, and we're getting connection, but then we go to where we want to see ground on the system, over here, we get no connection. So even though we follow it through, it gets through, comes to this side, comes down to pin 3. When we actually test if it comes to pin 3, it doesn't. But when we flip over the board and go to pin 3, the other side of the board here, it's connected. So it's almost like coming through the board is where the break is happening. So instead of hunting for the exact point where this ground is breaking, I'm just going to solder a fresh wire from the ground terminal to the input of the regulator, which is the most important step, and then it will go through to the rest of the system anyway. If there's a break here, it will now find its way through the regulator, ground, and back out to the system. It's the simplest way of doing this, and sometimes it just isn't worth the time looking for the specific location when it's a nice easy fix. Because we are going to be doing a clean power, I'm going to wing this around here, so we want it roughly there. So let's just take the iron. And then when soldering big pads like the battery terminal, especially when there's battery acid as well, you want to make sure you use flux, and that you also leave your iron on for longer than you normally would. So it's going to take longer to eat through the nickel plating of the battery spring, as well as if there's any battery acid there. So you put a bit of solder on, you wait, and then once you see the solder start spreading, you can move away. And that's now eaten through and got a good connection on the battery terminal there. The other side, we can pre-tin this, even though it's done, just a blob of solder. And then we can go from here and you want to avoid the screw holes. So anyway, you see kind of a hole and a cross, or these holes, just try and avoid the holes in general. But we will just place this here. And there's a fresh ground. So position wire wise, probably want to do that for now. There we go. And let's see if that's fixed the problem. It probably has. I should hope it has, because it had no ground. If not, we'll check the fuses. So we grip on that one. And we grip on this one with 3 volts. And then we turn on. Nothing. So let's do the multimeter and let's check if we have voltage. So the input here, we have input and power. We should be receiving power. And we're not getting power. Let's turn it on. Helps if we turn on. There we go. So the regulator is getting 2.9, which is right. The system output is nothing. So either the regulator's dead or we still haven't recovered ground fully. But we have power into the regulator. Yep, and we should be getting 5 volts out here and negative voltage here. So the negative voltage is working, but the 5 volt output isn't working. Ah, hang on, that's flickering. As I'm touching with the multimeter, that's actually creating a ground again. The ground is really messed up on this board. So now I have a good ground when I'm holding there. So the regulator looks like it's not actually outputting the 5 volts. So the other thing I can do is to set the bench to 5 volts, and I can just directly power the output of the regulator. And I think that's booted the console. So if I just flip this over, so it's easier to see, and this is just going to bypass the entire regulator and go straight out to the 5 volts. We can also see there's your problem as well. There's your bad ground, it's not even soldered in. So before I bother bypassing that, maybe we just solder the regulator in. So even though it looks like it's in, we've actually got solder blobs. We've actually got solder blobs on top that look like they're soldered, but underneath it's just broken. So I'm going to do a quick fix on this by pushing with my finger together, trying to squeeze this through. And warm up both joints at the same time if possible. Just get this out of the way. What you can actually do as well to make this easier, if you've got a desolder pump, you can free up these holes with a desolder pump. A cheaper option, if we get desolder wick, which we sell on the store, so this helps to wick up excess solder, as the name suggests. Put a bit of flux on the pads, put the desolder wick over, warm up with your iron, and it will wick away the excess solder, and you can see there's the hole now. Do it for the other one, and you can see we have the hole back. So that's a way to get the holes back in the board. And now it should be a simple case of seeing if we can push these See if I can push the regulator pins through, which I can't really push through. But again, these legs have also got contaminants on. So if I just put flux on them, desolder wick these legs as well. And let's see if we can push them legs through now the cleaner. And no, so because the legs look like they've snapped, they don't go all the way through. So this will be a wire fix to get them to make connection this side. The problem with this is it's not going to be mounted very firmly. So I can actually mount them on this solder here to keep them in place, but I don't believe that's going to make a connection. But then again, if these are actually vias this side, and I simply solder from this side, we might get a connection. If I can get that to naturally go through, and then also this side. We may be in luck to see if this has made connection. So I'll grab my other testers just for quickness, and let's test ground here to the other side, and nothing. Oh, actually, yeah, that was just the flux. Yep, I just want to make sure I'm confident that is definitely connected. Yep, and that is. So it looks like we've got it by soldering this side and letting the solder flow through. But if you had trouble, I would just send a wire from here going over, if we, have trouble in the future with that. So now we have power again. Let's try once more. We've got the ground wire fixed back on as well. So I'm hoping now, with good ground here, let's just get these connectors on. Oh, change that to 3 volts before I connect. That was a close one. There we go. Yeah, and there we go, it's booting. So turn off, turn on. Yeah, so if I turn that over, you'll see the power light. Turn on. So it's on, but we don't get a power light. Now I'm saying it's on, it's based on the current draw. So we could do with a screen to confirm this more, or at least audio. So let me just grab this known, well I say known working board, I'm not sure that it works. Just grab a speaker. So I should whip this speaker off this board. And we have the screen as well. So let's just put the speaker temporarily on this board. Speaker's also had something done to it because that doesn't want to solder. So there's been some work here as well, so let's clean that pad up. Let's try and see what's going on first. I think it's just got a bunch of bad solder, old dry solder and a bit of corrosion, so flux and fresh solder cleans it up. Desolder wick, wherever that's gone, there we go. Let's put desolder wick on now to wick back up all the mix of old and new solder and make it nice and clean. There we go. Bit of IPA. Clean that up with cotton wool buds. There we go. And let's just chuck this speaker on. Again, just temporarily, so I'm just going to put it this side. Fit. And for good luck, we might as well fit the screen as well. And let's power this one up. So that on there. So even though we're not getting a power light, maybe it's just the power light's also got a fault. So turn on. And no, so that's drawing power as if it's powered up, but it's not powering. So that could be a bad ground further up in the board. And to test that, let's first check the voltage regulator, see if we have power, which we had before. So you see we're getting no ground here, or no power here. So this regulator seems to be dead on the 5 volts, but powering the minus 16. So it's as if the 5 volt side of this regulator is dead. So I might as well install a clean power, because that's one of the things it wanted anyway. The negative rail, which is what we need working, is still working, and the 5 volt rail is the thing that's not really working well. So if we just chuck on a clean power, it will probably solve the problem anyway. So let's just rest this on top here, and we can do this because the inductor's still underneath. It's not really an issue. We just need to use plenty of solder. And the iron was actually on. Come on, iron, come on. There we go. So use plenty of solder. And then if we place them in position, we can nicely bridge the gap between the two. Probably come down a bit. And I reckon about there's a good position. This is easier if you remove the original regulator, but in this case, because we've got the IPS and the brightness might need the control, depending on which board he has, which IPS screen he has, I'm just going to leave the original regulator on anyway. So this gets the input to the clean power. And now the clean power will take over and provide 5 volts on the 5 volt rail here, which is dead. And hopefully that's the last of our issues. There's the ground. This is just a securing pad, and the important one, the 5 volt pad. So do we have them? Yep, you can see we've got connections there now, and connections there. So the clean power should now take over that dead 5 volt rail. And let's see. There we go, we're drawing more power now. I'm guessing we'll hear a beep maybe. There you go, we've heard a beep. So pretty sure that's working. Turn that off. And let's just grab his IPS screen. Connect the ribbon. And I'm guessing on this model or brand, this will be the power wire. So this will want to go to the power switch. and voila, there is the screen. So that's now a working console. And you can see there's the screen working. So the main problem with this was, one, the power regulator is now dead, which is likely because it was probably driving this IPS screen, and hence the entire reason I built the clean power board was for this reason. You power an IPS screen and mod the console, and it uses that much power, it is going to kill the original regulator. And that's exactly what it's done here. It's killed the 5-volt rail of the regulator because this draws off the 5-volt rail. So that's why I made the clean power, to solve that issue. The second issue is simply we have a broken ground between the battery terminal and here, and also the DC jack. So by bridging this side, this should go backwards in and allow the DC jack to work and the battery power to work as well. The only other thing to note as well, I see it's got the universal power switch on here. On the Pocket, when you mount the universal power switch flat like this, let me see if I can show you, and we put the power switch in the Pocket. If we were to mount this, you can see, get it that side, that the power switch is very close to going under. So you can see in this case, the power switch can go under, it can work, the power switch can work, but it can also, if you just push down a little bit, go under. So it's a bit intermittent there. So if you're going to install the universal power switch on the Pocket, I'd probably recommend, just lift this off, to lift this up effectively on here. You imagine the power switch is flat like this now. If we lift it up like this, so this power switch is going downwards a little bit, it will help solve that problem. We obviously can find better solutions for this power switch, I think. But for now, it works, but I would definitely recommend, let's see how we get this off. We would want to use desolder wick again to clean up the pads. Let's just remove this solder from all around the power switch so we can reinstall it. And I'm not sure whose power switch this is. I don't think it's ours. I know Handheld Legends can make their own. I know we make them. And I know a bunch of other people make them, including Chinese clones. But they're all pretty much the same. We all use the same power switch, I think. The same slider. Although this does look a little bit worse than ours. But you can get that issue on all versions. And it's simply the thickness of the power switch. So there we go. We're finally getting that off. So now that's off. The idea, as we mentioned, was to install this power switch, but we want to tilt it. So if we get it to the edge, we want to tilt it slightly down like this. I mean, you can do it quite extreme, it doesn't matter. So to do that, we can, let's position this visually, about here, goes over them switches, and I can just twist like this then. So I'm going to grab solder that's now disappeared. Grab some more solder. And I will fill this pad with solder. I'm going to use that as the anchor point. I'm going to grab the power switch here. And then when it's in place, which would be about here, I'd say is a good place, I'm going to just warm it up to tack it in. So I'd say about there. But now if you warm it back up, because it's only attached by one pad, and tilt down a little bit. Let's see if that works better in the shell. And as I mentioned, this ain't great. This isn't the kind of experience you'd want installing a switch. But at the minute, we haven't really paid too much attention to find a replacement switch on the market. So I'd say we want more of an angle still, because that's better and gets it every time. Yeah, actually, that's fine. So if you push down, you're never going to go under that now. So that's getting the power switch. So you can see the angle we've put on it, just a slight angle on the board. It's a bit of a hack to get around that issue in a sense for the pockets, but it works. So there's that. And you can see you don't even have to be that accurate on your position. So we're a little bit off here, but if we just blob solder in, it reaches over like that fine. This one, blob solder, it's going to naturally bridge. This one, blob solder, it's going to naturally bridge. And this to there. So you can see even without that much accuracy, you can get the power switch on. Let's chuck this back on as well, the power for the IPS screen. And now when we have the switch in the case, let's power this up. That on there, that on there. And we're already juiced up. So we already have the power. But let's just now slide that way, off, on, off, on. So you've got a good working power switch now. And that again, on here, you can see if we push down, it's going to hit every time. So that's another one repaired. There's now a clean power on there. The IPS screen's in. There's an amp, so I'll just install the amp, get it generally up and running and ship it back. So I hope you found this useful. And again, it's just another diagnostics of how to find problems. This time it was a ground disconnection, which is important when you're using multimeters, that when you're testing ground to see if something's got power, remember to always test it by putting the ground on the part of the chip or the part of the circuit that you're expecting to receive power. So if you're expecting this regulator to receive power, make sure you touch the ground near there if you're having issues, to make sure you have ground between them, or just do continuity from the source ground to other parts of the board on ground. It's rare you get ground fault, but it does happen. And that's another one repaired.